Alright, this is lesson 14 of module 1. Today our objective is to divide decimals with a remainder using place value understanding and relate to a written method. We're actually just going to be really taking that place value method and we're going to be showing you how it works with the standard algorithm. Essential question, I want you to start thinking about what you actually do with the extra pieces when you divide a number equally between groups. What do you do with the leftover pieces? Okay, question 1 said draw the place value discs on the place value chart, show each step using a standard algorithm. Okay, so first thing I'm going to do is I'm going to come over here and I'm going to write my number in as 5 and 241 thousandths. Now I'm going to model it first. 5 ones, so I'm going to go 1, 2, 3, 4, 5, 2 tenths, 4 hundredths, and 1 thousandths. So there's my place value modeling. Now it says I'm going to be dividing into 3 equal groups. So I'm going to take my bottom down here and I'm going to split up to 3 equal groups. And this here would be model group 1, group 2, and group 3. Now first thing I want to do is I'm going to take this 5 and I'm going to split it equally between these 3 groups. So I'm counting 1, 2, 3, and I can't split the rest of them up. Now in the standard algorithm, the question is 3 will go into 5 one time. And as you can see, there is 1 in each group, and that matches. Now we're going to go ahead and subtract, and because we have to get rid of what we used, so there's 1, 2, 3 of them, and we ended up with 2 left over. Okay. Now over in the standard algorithm, the way it's going to look is I like putting this X here because I know I had 1 times 3 is 3. That's how many I used. So 5 minus 3 gives me 2. And that's what shows me my remainder over here in the ones place was 2. Now, these remainders here, I need to bring over. I know for every 1, I'm going to have 10 tenths. So I'm going to come over here, and I'm add them in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was one of them. Now I'm going to bring the second one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I had 2 tenths. I added 20, so I'm going to have 22 dots in this space. If I come over to my standard algorithm, first thing I'm going to do is I'm going to put my decimal point in the same spot that it was in my dividend, and I'm bringing down the next digit. If you notice now, I have 22 tenths, and that's the same as when I had brought them over. Now I'm at 22 tenths. I'm going to split them up equally between 3 groups. So I'm starting here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now I know I had 22 to start with, so I can't go any further. The same if we look at the standard algorithm. My question is, how many 3s can I get out of 22 without going over? And I know that'd be 7, so I'm going to write that above the tens place. because 7 times 3 is 21. That's how many of them I used. Now, if I come over here and I subtract all the ones I used, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I missed one over here, 21. Now here's the one left over right here, all by itself. As you can see, we had one left over on the standard algorithm also. Now once again, we're going to regroup. We have to take this remainder, we're bringing it over. We're going to put 10 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can see here we had 4 in there, we added 10, so there should be 14. In the standard algorithm, when I bring down the next digit, you can see we have 14, exactly what we showed on our place value chart. Now we're going to divide those 1400s up to 3 groups. So we start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we know we cannot get any more. So we had 4 in each group. If we look at the standard algorithm, 3 will go into 14 4 times, because 4 times 3 is 12. And that should give us 2 remainders. So if we subtract the 12 over here from our top, what we used, we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see we have 2 left over. We're going to regroup these, 10 each, 3, 4, 5, 6, 7, 8, 9, 10. We're going to bring the second one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know we had 1 in there, we're about 20 over, so we should have 21. When we bring down our next digit, you can see we have 21. Now, we're going to split these up evenly between the 3. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So we can see that we ended up with 7 in each one. And we know that 3 will go into 21 7 times, because 7 times 3 is 21 with no remainders. And we know we used all 21 of these. So when we subtracted them, we would have no remainders. I'm just going to X out the whole thing, no remainders. So if we go down to our place value chart down below, we can see that we had 1 here. We have 2, 4, 6, 7 tenths here. We have 4 hundredths and 2, 4, 6, 7. And our place value is right here. So that's 1 and 747 thousandths. As you can see, that's exactly the same answer we had on the standard algorithm up top. Okay, question 2. I'm going to start, instead of using just dots, I'm going to start drawing place value discs. I think we're at the point where we can do that. First thing I'm going to do is I'm going to model it. And we know we have 5, 3, 7, 2. And I'm going to put 5 in here first. 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6, and 7, and 2. Now, in accordance with the problem, it says we're going to be dividing this up into 4 equal groups. So I'm going to go ahead and make myself 4 groups. Now, the first one says 5. We're splitting the 5 up into 4 equal groups. So we got 1, 2, 3, 4. Okay. So we take away the 4 we used, and we had 1 left over. We'll bring that over. This time, I'm going to put a 10 place value in here. So I know that I have 13 tenths. Let's see how that looks over here. 4 will go into 5 one time. I know 1 times 4 is 4, so I used 4, and I'm going to subtract that, 1, and the 3 comes down. There's my 13 tenths. By using a place value disc and drawing the numbers in there, it will help you so you don't have to count so many dots. Now we're coming back over our place value. This time we're going to divvy up 13 between 4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know we can't get any more. And we know we used 10, 11, 12. And we have 1 more remaining, which we're going to bring over. And once again, as another 10 we're bringing over here. So you can see we have 10, 12, 14, 16, 17 hundredths. Over here, and the standard algorithm, we knew 4 goes into 13 3 times, because 3 times 4 is 12. We're going to take those away, and we had 1 left, and we drop down our hundredths, and we can see we had 17 hundredths, which is exactly what we have left. Now we're going to go ahead and divvy up the 17 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so now we're going to take away the 16 we used. There's 10, 11, 12, 13, 14, 15, and 16. We have 1 left over, which we're going to regroup 10 over to the thousandths place. Well, we know 4 goes into 17 4 times, because 4 times 4 is 16, and we had 1 left over. We bring down our next digit, which shows we have 12 thousandths, and that's exactly what we ended up with up here. Now we're going to divvy up the 12 thousandths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we were going to use all 12. We subtract those and we have no remainders. On the standard algorithm, 4 goes into 12 3 times. 3 times 4 is 12, so that's what we used. And we have 0 remainders. If we look over in our place value chart, we can see we had 1 1, we had 3 tenths, 4 hundredths, and 3 thousandths. And that is exactly the answer we got with our standard algorithm. Okay, now we're going to solve using the standard algorithm since we've been going. We're going to start off with 64 hundredths, and remember when we're writing this, the divisor, which is the one that's determining the amount of groups, always goes on the outside. We have 0 and 64. Now the first thing you need to do with standard is make sure you transfer that digit up, that decimal up, because you know 4 are going to 0 0 times. Okay. but 4 will go into 6 one time. 1 times 4 is 4. So we could use those 4 tenths, and we get 2 remainders. Now we're regrouping over to the hundreds, so it's actually 20 and 24. So 4 goes into 24 6 times, because 6 times 4 is 24. And we have 0 remainders. So our answer is 16 hundredths. Coming to the second one. Once again, my divisor is going to go on the outside. My dividend is going to go inside. And I'm asking Quentin, how many times 5 will go into 6? It will go 1 time. 1 times 5 is 5. We're going to subtract what we've used. That gives us 1. We're going to carry our decimal point up. We're regrouping because that 1 becomes 10 tenths. Bring down a 4, we got 14 tenths. 5 goes into 14 2 times, because 2 times 5 is 10. We end up with 4 tenths left. Well, we're going to regroup those, make those 40 hundredths, and bring down to 5. We have 45 hundredths. 5 goes into 45 9 times, because 9 times 5 is 45. And we have 0 remainders. So our answer is 1 and 29 hundredths. Our last example on C, we have 6, and we're dividing it into 16 and 404 thousandths. Now this one's got a little trick to it, okay? We start off, we know 6, or yet, there it is. 6 cannot go into 1, but 6 can go into 16 2 times. And 2 times 6 is 12, so that's how much we used. And we have 4 left over. We'll make sure we put that decimal in there. We're going to bring down our next digit, so now we have 44 tenths. Well, 6 will go into 44. Well, I know 6 times 7 is 42. So I know it'll go in here 7 times. 7 times 6 is 42. And we have 2 left over. We're bringing down our 0. We know 6 will go into 20. Well, I know 4 times 6 is 24, so 3 times 6 has to be 18. Subtract what we use, and we have 2. Bring down our last digit. Now we have 24, and I know 6 times 4 is 24. So 4 times 6 is 24. And we have 0 remainders. So the answer, the quotient, is 2 and 734 thousandths. Okay, question 3. Miss Mayuko paid $40.68 for 3 kilograms of shrimp. What's the cost of 1 kilogram? Okay, the first time I read it was just for the gist of it. Now I know she paid $40.68 for 3 kilograms. They want to know what the cost of 1 kilogram. So if I was to draw a tape diagram, I would have it looking like this. Tape diagrams help us determine what we have to do to solve the problem. I know the total here from the problem was $40.68. And that was for 3 kilograms. So I'm going to split this up into 3 kilograms because this is 1 kilogram. Now it says they want to know how much 1 kilogram is. So I know that if I take $40.68 and divide that by 3, it's going to tell me how much 1 kilogram is. So 3 are going to 4 one time. 1 times 3 is 3. So I'm going to subtract that so I can see what I have left. I have 1. Bringing down my ones place. 3 are going to 10 3 times, because 3 times 3 is 9, leaving us 1 left over. We have to place our decimal up in the answer. And we're going to bring the next digit down. So now we have 16. 3 can go into 16. We know that 3 times 5 is 15, so it's going to go 5 times. 5 times 3 is 15. Subtract what we have left over. We have 1, and we're bringing it down to 8. 3 going to 18 6 times, because 6 times 3 is 18. So I'm going to bring this up to here so I can finish it off. 18, and I'm going to subtract 18, we have 0. So we know 1 kilogram of shrimp cost $13.56. Question number 4. The total weight of 6 pieces of butter and a bag of sugar is 3.8 pounds. If the weight of the bag of sugar is 1.4 pounds, what is the weight of each piece of butter? Okay. So once again, I'm going to do my tape diagram so I can make sense of it. Here is the total weight, and we know the total weight was 3.8 pounds. Now it said the bag of sugar was 1.4, so I know it's going to be right about here. That's 1.4 pounds, and I know this was the sugar. Now I know this is the butter, but it says that there were 6 pieces of butter. So I'm going to take, and I'm going to split this into thirds first. And I'm going to take those thirds and split them again so they're into 6. So now I have 6 sections of butter. And they're saying that the total butter here, this total amount of butter right here, is, oh, they're not giving it to us yet. That's what we got to solve. Well, we can see this is a 2-part problem, because they want to know what the weight of each butter is. So the ultimate answer is we're looking for 1 piece of these butter. So in order to solve this, first thing we have to do is figure out how much the 6 of them weighed. And we know that the total weight was 3.8 pounds. And we know the sugar was 1.4 pounds. So we know if we subtract those, we can get the total weight of the butter. So I like doing them horizontally, 3 and 8, 1 and 4. Subtracting, I lined up my decimals. 8 minus 4 is 4. 3 minus 1 is 2. So I know the total of this, total weight of the butter now is 2.4 pounds. Now the question is asked, how much is 1 stick of butter? Well, I know there's 6 of them here. So now the problem now becomes, there it is. So I know I have 2 and 4 pounds of butter divided by 6 equals. Now a couple different ways I could do this. One of them, I know 24, using my basic math facts, I know 24 divided by 6 equals, well, I know blank times 6 equals 24, and that's 4. 4 times 6. So I know 24 divided by 6 is 4. So 24 tenths divided by 6 would have to equal 4 tenths. So I know that each one of these would have to equal 4 tenths. So each piece butter weighed 0.4 pounds.